All right, so just kind of a quick review of the stuff we've been doing. If I throw a problem up here, say something like this, where I've got maybe 3 times 2x plus maybe 7 minus an x equals, oh, I don't know, 24, like this. All right, just help me review the steps that we've been looking at right here to solve that equation. Where am I going to have to start here, gang? Yeah, and that property again is what property? Distribute. So 3 times what here first? 2x is? I've also got to take the positive 3 times the positive plus 7. So that's a positive 21, right? And then I'm going to bring the minus x with it, and that's still equal to 24. So I've gotten rid of parentheses. If I look at the left side, on the left side here, is there anything I can combine? I could, couldn't I? What could I combine, Lauren? You're shaking your head, yes? 6x and a negative 1x, right? So what's a positive 6x and a negative 1x going to combine to? Or 6x minus 1x? So it's really 5x plus what? Equal to what value? Okay, so when I get this part right here, it's just a 2-step equation. We've been doing this a lot lately, right? Okay, subtract how much, gang? Okay, so when I do that, we got 5x is equal to 3. So I'm going to take 3 and divide it by what in the end? 3 and divide it by 5. Okay, somebody punch that up for me. See what you get. Who's got 3 divided by 5 for him? 0.6. Okay, good. So the idea was distribute, combine like terms if possible. 2-step our way through this. Now guys, today we're going to start looking at some new stuff, maybe more complicated stuff. I'm going to tell you, it's the same gosh darn stuff, but we're going to add one more step to it. Okay? We're going to add one more step to this. And this is what this is going to look like today. In your section for 5.3, says to solve equations when you have variables not on just one side, but now, what's it say here? Solve equations with a variable on, that means something like this. That means something like this. What if you have, like, say, 4x plus 17 equals 2x minus 19, okay? Do you have x just on one side of an equation, or does it exist on both sides now? It's on both sides. That's what that's talking about. Now, I'm going to tell you this right now. Everything is exactly the same, but we're going to add a new step to this, all right? Pretty easy to do. All right, so goal-wise. Talk to me goal-wise. Who would volunteer to read that for me? My goal. How about a volunteer to read that?
Solve equations with variables on both sides and apply to real-life situations.
Solve equations with variables on both sides, and gosh darn it, maybe we should apply it to a real-life situation. Oh, geez. Okay, no worries. Good deal. All right, grand, great, groovy, gnarly. All those words that start with G, right? Doesn't G start with, doesn't gnarly start with a G? Gnarly. Isn't there like a brand of chips or something named Gnarlies or something like that? Gnarlies? Gnarly Gnats. I wish I had a team called the Gnarly Gnats. The Fighting Gnarly Gnats.
Next year, fantasy football.
Next year. What's my team? Oh, my team right now in fantasy football, you know what it's called? Want to hear it?
Sure.
Weapons of Math Destruction. Weapons of Math Destruction. And I'm in the championship game, baby. Woohoo! Go Destruction. All right then, haters. All right, let's roll. Haters gonna hate. Oh, love, love, love. Kill them with kindness, right? All right, rules for solving equations on both sides. Rule number 1 says to do what, guys? What's rule number 1 telling us to do? You always, always, always got to distribute. I'm going to start with a problem right up here. Okay, I'm going to start with a problem right up here. We're going to walk our way through this. So let's do something like this. Let's say that we've got, how do I want to write this? I know what I'll do. I'll zoom up on this. Make some room. Move over, bacon. Now there's something leaner. Rule number one. I think we can all see that, can't we? Rule number one says to distribute. So let me think. Let's go 3x. Oh, I'm sorry, back up. 3 times x plus 2 plus 4, maybe. And I'm going to run out of room here a little bit, but that's okay. Let's go equals, I got to think, 6x. All right, I got to think. Six x plus 4. Okay. We're going to walk our way through our new steps, right down those boxes to solve this, okay? Solving equations with variables on both sides. First of all, guys, is there an x on the left side? Yeah. Is there an x also on the right side? Yeah. There is. Okay, that's what that means, variables on both sides. So when I start working with this, step one still says to do what? You got to do what? You got to distribute. You got to get rid of those gosh darn parentheses, okay? Do I have parentheses in this? I do. Okay, I do. So let's rock and roll this. Where are you going to start, kiddos? At the left. All right, Brittany, you want to carry on with that?
Take 3 times x with 3x.
Okay.
And then take 3 times 2 plus 6. And then plus 4.
That equals what? Okay, so the original problem I started with up there, we got rid of parentheses. That was our first step. So are we done distributing?
Yes.
We're good. We're good on it. All right. Now, take where we're at right now. Just what I've got written in that first box up there. What does step 2 below that say? Combine like terms. And I think I want to add something to this. I want to do 2 things. Go back up to your distribute first. Okay? Does every single problem always have a set of parentheses in it? So maybe I should put the phrase up here. After distribute, I should say distribute if what? Parentheses. If maybe it's possible. Okay? Might be situations where it's not possible. Would you guys buy that? Yeah. Okay. Second part, I want you to do this. Combine like terms on both sides. Are you always going to be able to combine like terms? No. So on both sides, if what? Possible. If possible. All right? So we're looking at combining like terms on both sides if possible. When I talk about both sides, there's a left side of the equal sign, there's a right side of the equal sign, right? Okay, so take a look at the left side. Look at this. Look. Just look at it. Whoa. Anything you can choose to put together on the left side? A positive 6 and a positive 4 yields a 10. So how am I going to rewrite my left side after you combine like terms? 3x. So left side will be 3x plus 10. We're on a roll. We've got this. How about the right side then? Look at the right side, the 6x plus the 4. Anything I can choose to do there to put together to simplify maybe just the right side? Can 6x and positive 4 be combined? No, they're not like terms. So I have to leave the right side just as is, right? 6x plus 4. So I've completed the first 2 steps, so we're good. All right, so what's new for us then? Well, what's new is right here. What's it say to do? Get the variables on the what? Same side and a constant on the other. Okay. Variables are anything with a what? Letter in it. Okay, here's how this is going to look. Okay. I work so much better if the variables are on the left side. How many of you guys say, I like my variables being at the start of the problem instead of at the end of the problem? Okay, so here's the deal. Listen carefully to this. If I want variables to be on the left side right here, don't I have a variable right here on the left side? Would you guys agree? Okay, if I want variables on the left, do I really want this 6x right here then? Okay, here's the new part of this. The new part of this is very simple. Okay. If you don't want variables on the right side, get them to which side? Left. Here's how you do this. Ask yourself the question. On the right side, do you have a variable? What is that variable?
X.
How many of them?
3.
On the right side, there are 6 of them. I don't want this here, do I? I want all the variables on that side. Guys, question for you. What kind of 6x is this? It's a positive 6x. Okay? So here's how I'm going to handle this. I'm going to rewrite the problem to this point right here, and this is what's new for us. So we were at 3x plus 10 equals a 6x plus 4. And a variable I really don't want on this side is right here, right? I don't want that there. If that's a positive 6x, how do you eliminate a positive 6x? Subtract it out of there, okay? So on each side, I'm going to subtract a 6x from both sides. Now guys, watch what happens here. Watch what happens. Since I'm subtracting not a constant, but rather a variable this time, I have to subtract my variables with variables. Or in other words, combine like terms again. So you're really doing 3x minus what here? 3x minus 6x on the left, right? What is 3x's minus 6x is going to get you? So this is now negative 3x. On the left-hand side, what constant do you still have?
10, 4.
Plus 10, right? You understand why the left is now negative 3x plus 10?
Yep.
I subtracted the 6x from the 3x, but there's still a plus 10 on the left side, and we cannot combine those two, right? On the right side, you got a positive 6x and a negative 6x, which are really going to do what to each other, gang? What are these going to do to each other here and here? They're gone, right? What are you left with on the right side then?
4.
Positive 4. Oh my goodness. I've simply gotten the variables on the same side. Instead of having variables on two sides, we now just have a variable on one side. Hey, I have a question. When I get to this point right here, isn't it just a matter of stuff that we've done in the past again now?
Yeah.
The part I highlighted here in the middle is the new step, isn't it? I want to back up. What was the first thing we looked at doing here, guys? Distribute. Show your hands if you understand what I'm talking about when I say distribute. That's easy, right? Show your hands if you understand what I mean by combining like terms on both sides. Okay? Now, how about the next term, or the next step, I should say. This is the new one. I don't want variables on both sides. I want them on one. So take what's on the right side, do the opposite. But I've got to do it to how many sides?
Both.
Both sides. I didn't want a positive 6x here. Get rid of it. Subtract it. Okay? All right? In the words of Ken Harrelson, he gone. I can't stand that man. Nor can I stand the Chicago White Sox. Edelman, are you a White Sox fan? Oh, even worse. Jesus. Just when I thought it couldn't get any worse, it did. Do I have any Packer fans that are Yankee fans? Hez? Izzy? Glutton for punishment, eh? How can you be a Cubs fan but not a Bears fan? I don't get that.
I just don't like the Bears.
Because you like the Packers.
I don't get it.
They're not supposed to like
I'm loyal. I'm Minnesota loyal. Go Twins. Go Vikes. Go Wild. Go Wolves.
Go Wolves!
All right.
I
Hey.
actually don't like
Isn't this just a two-step our way through the rest of this? Isn't this just two-step your way through this?
Yep.
What's my next step, guys?
Subtract 10.
Subtract 10 from both sides. So I'm subtracting 10 from both sides. All right, watch what I've got. What are the 10s and 10s going to do to each other?
Cancel out.
So I've got negative 3x equals what on the right?
-6.
Negative 6. So finally your last step then is to undo multiplication or division. What are you going to divide both sides by now? Divide both sides by a? Divide by negative 3. What is negative 6 divided by negative 3, gang? Negative 6 divided by negative 3. Where are you? 2, right?
Yep.
Do you guys understand this new step that's been incorporated to solve equations when you have variables on both sides now?
I do. Yes.
All the same, the only thing I added was this third step, right? Right? Okay, let's look at what the notes say. I'm going to minimize. Let's try one together. Example 1. Okay? Example 1. Let's check it out, kiddos. Solve. 4x plus 7 equals 6x plus 1. I'm going to go right through the menu. Any parentheses? No. Do I need to distribute them? No. Look on the left side. That's good. You can't see that number now. Okay? 4x plus 7. You got it? Can I combine anything there? How about now? Can I combine anything here? Done. So I'm at step 3 now, right? What do do you guys think I'm going to do next? Somebody tell me what you think you're going to do next.
You're gonna go to Disney World.
I'm not going to Disney World. I've already said
Subtract
it.
6x.
Subtract 6x from both sides. I don't like having variables over here. Okay, so do what? Well, why are you subtracting? Positive, right? Do it to both sides, but set it up with x's, right? What's 4x minus the 6x going to get you on the left?
2x.
Negative 2x. What's the whole left side going to look like? What's that going to equal on the right?
1.
Because those will.
Cancel it.
Are you guys following along okay?
C.
All right, so two-step my way through the following here. Help me.
-7.
Yep. And what's that going to yield on both sides?
Negative x equals negative 6.
Oh my goodness. There's really nothing different here. We've just added a new step, haven't we? Okay, so what are you going to get for a solution? What are you going to get for a solution? X is 3. Okay. Understand what I'm doing here? It would have been negative 6 divided by negative 2. Final solution would have been 3. Hey, I can always check. Come back up here, gang. On the left side, what's 4 times 3? When I substitute the 3 back in here, 12 plus 7 more gets me what? 19. Left side's 19, right? Go 6 times 3 plus 1. Are they the same on both sides? So 3 has got to be correct, isn't it? With me on this? All right.
I don't know why.
No, I got to finish the notes here. I-Z-Z-Y. That's just the first page. We got 3 pages, don't we?
We need to get good.
Go. On your own. Give these a shot. Make sure you understand that. When you've got solutions, check with a neighbor. Make sure you agree. If you disagree, talk about why you disagree while I corn nut it up for a nut. Huh?
Right? I do that with carrots. Austin Page can actually like do it someday.
You need to do it with spaghetti noodles. That works better.
Or carrots. Carrots works pretty good.
Again, when you get an answer, check with a neighbor.
Girls play at night too.
Just one JV game and one varsity team. No, the boys have 2. The boys have a JV and a fresh sophomore.
I don't know if they have JV. I don't know they have freshmen.
Neither one of them have to. You just have to move the X from the right side to the left side.
If we go to where all the freshmen are on JV, I would be in front of Tim, Taylor Brown,
First one's okay.
T. Brown. I love the second one. Like at practice, Tim shoots the 3.
What's that?
Times for game start.
Lauren, are we 4 or 4:30 tonight? 4 o'clock?
It should be 4. We got
I think it's 4 o'clock.
Just got that for you.
Do you need more time with those 2? How about one volunteer to talk me through the first one? One volunteer to talk me through the first one. All right, Cass, talk me through, kiddo. So the left side and the right side subtract 4x. Okay, I agree. How many agree with what Cassidy's doing here so far? Okay, good. Carry on.
So that equals negative 1x plus 4 equals 1. And then he
I do that, I've got negative 1x equals negative 3.
Yeah. And then divide 1x by negative 1.
And what'd you get for a solution, kiddo?
X equals 3.
I agree. Good job. Very good job. 3. How many had 3? Excellent. Excellent, excellent, excellent. How about my next one, John? You want to run me through this?
Yep. Subtract 2x from each side. Gives you 3x plus 4 equals 10.
3x plus 4 equals 10.
Subtract 4 from each side.
So we have 3x equals 6.
Yep. And divide it by 3 and you get x equals 2.
And 2. Okay, very good. Very good. Okay, well, let's look at some examples that are kind of real to this right here. Some real life examples up here, guys. Here's the situation. It says the amount of fencing that's needed to enclose these 2 flower beds, what's the value of x? I suppose I better find something right here, huh? Okay, I got an idea. I got an idea. You want to hear it? Here's my idea. I'm going to call this 2x, and I'm going to call this a 4. I'm going to call this an x and a 6. Okay, it says the same amount of fencing is needed to enclose these 2 flower beds. What's the value of x? Okay, what's the value of x? Well, here's the deal. If these were gardens right here, okay, or flower beds, I guess is what they are, it's saying the fencing that you need would have to be exactly the same all the way around here as it is over here, right?
Yeah.
We got to find the value of x that's going to make that true. So basically what we're saying is, aren't we saying that the distance around, what's the word for distance around something? Perimeter. It's basically saying the perimeters are what? Perimeters are what? Isn't that what I'm saying? The perimeters or the distance around them is equal? Isn't that what that's saying? Isn't that what that's saying? All agree? Well, the perimeter needs to have all 4 sides taken care of, right? You guys agree that these beds are rectangular in shape, right? What's going to be true about the opposite side's length of a rectangle then? If the bottom here is 2x, what's the top up here? If this is 4 on the right, what's this on the left? What am I going to put up top in the second rectangle, gang? How about the left side? What's true about the perimeters here? They are going to be equal. Let's write an expression for the perimeter of the first rectangle. Let's see, a 2x and a 2x. If I add them together for the perimeter, what's that?
4x.
So the perimeter here, 4x. Plus, what's the 4 and 4 going to add up to when I combine those terms?
8.
You guys agree the perimeter of the first expression, or the expression for perimeter of the first rectangle is 4x plus 8?
8.
All agree? What would your expression be for, oh, I really screwed this up, didn't I? No, I did not. I did not.
2x plus 12.
2x plus 12. 1x is 2x. 6 and 6 is 12, right? Hey, I got a question. Once I've set up my equation, doesn't that look very similar to what we've just done? Okay, you guys find x now. Go. I think I got an answer. Yep, solve it now. I think I got an answer. Anybody else got an answer? Brittany, what do you think?
X equals 2.
X equal 2. Anybody else get x equals 2?
Yep.
Lainey, what'd you get? Anybody else get 2? Talk me through it, Lainey. What do you got to do, kiddo?
I subtracted 8 from itself over 12.
Okay, so you went this direction. You subtracted 8s first, right? So you have 4x equals 2x plus 12. Is that right? And then subtract what from both sides?
And then I subtracted.
Oh, I messed that up. That should be 2x plus what? And then subtract a
I subtracted 2.
2x from both sides. So I've got 2x equal to 4 when I do that.
And then I divide them by 2.
Very good. All right. So let's have you guys try one right here. I'm going to have you put your work over in here. It says the perimeters of the two triangles are equal. What's the value of x? I'm going to call this distance maybe a 7 and a 7 and an x. And I'm going to say that this is 2x. And I'm going to call this 4 and 4. Okay? You guys go ahead and give that a shot. It says the perimeters are the same. So the distance around the first triangle is equal to the distance around the second triangle. Put your work in this box right here. Set up the equation, solve. Show me that you know what's going on there. You might have to sharpen this. Go ahead and sharpen that back there. I got an equation for you first. Let's start that way. How about the perimeter for the triangle on the left?
Would be 14, or x
X plus
plus 14.
14, right? What's that going to equal, Brittany?
2x plus 8.
How many of you guys agree with my equation? I don't like that 2x on the right, so let's get that out of there. You guys tell me if I make any mistakes here, all right? Everybody agree so far? What is 8 minus 14? It's 6, right?
Yeah.
Positive 6, right?
Yeah.
8 minus 14 is positive 6, right?
No, negative.
Negative 6, right? Then I'm going to divide negative 6 by negative 1, in which case your solution will become 6. How many had 6? Awesome sauce and maize balls. What? Question? Good? Okay. I want to talk about one more example here quickly. I'm going to go ahead and go through one, and then I'm going to have you kind of finish these two problems up here on your own and check with me. Hey, guys, you're going to see something like this on the quick quiz today. I'm going to kind of split this right here. You might want to do the same. Here's a rectangle. Draw a rectangle right over here. Whoops. Draw a rectangle right over there on the right. Something that you see on the quick quiz today is going to say solve for x. Now it's going to be just one shape. We just got done comparing two shapes, right?
Yeah.
Now in this one right here, you're going to say, all right, what if you have something that looks like this? Say, for instance, maybe 3 times x plus 2. And up here you've got 7x. Okay? And your job is to solve for x. Now guys, first of all, what type of shape is that? rectangle. And what are some of the characteristics of the sides that I've labeled? In other words, the top side and the bottom side. What's true about those two sides? They're equal, right? So to set an equation up for something like this, I would say what equals what here? I'm going to call 7x equal to 3 times x plus 2. Okay? So in something like this, the top and the bottom are labeled differently this time, right? We don't call the bottom one thing and the very top the exact same thing. We have different expressions for them. But we know enough about rectangles to say, hey, the top length has got to be equal to the bottom length here, right? Okay? So help me out here. Where are you going first, kiddos? What do you got to get rid of? So what are you going to call the right side?
3x plus 3 times 2 is 6.
3x plus 6, and on the left side still a. So how about getting rid of that 3x now? How are you going to obtain that? Wouldn't I get that out of there by subtracting on both sides? Guys agree? How about on the left side? 7x minus 3x. 4x equals what value on the right? 6. So now you're going to take 6 and divide by 4. 6 divided by 4 turns out to be 1 point. Anybody know it?
5.
1.5. So don't lose sight of the fact that we did some stuff with perimeters comparing two shapes. We can also apply it to one shape when we know properties of rectangles. In other words, top side's got to be the same length as the bottom side. So I set the 7x equal to what? Set it equal to 3 times x plus 2, right? 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 Okay. Here's what I'm going to do. I'm going to do this first example. I'm going to leave these last two for you guys to try here and make sure we're okay with this. I'm not going to talk. You guys tell me what to write. First one. Give me a volunteer. How am I starting the first one?
Take 5x plus 5 times 3 equals 15. Take 2x plus 2 times 6
Plus, what on the end then, kiddo?
12.
All right. Subtract 2x, is he? All right. All right. Anyone? What's my left side?
3x plus 15 equals 4.
Okay. I'd buy that. Looks good. Looks good. Minus 15. Okay. What kind of 3 have you got, kiddo? Negative 3 divided by 3, right? What do you got? Can't be doing that when I'm almost 40. You know, 3 weeks from today. 3 weeks from today.
You're going to be 40. You're going to be a bodybuilder?
No, I'm gonna be an old fart.
I know a 40-year-old bodybuilder.
January 6th. Guys, here's what I want you to do. I'm gonna say 1, 2, 3, 4, 5. These need to be completed for tomorrow, okay? Don't lose sight of this idea. What kind of a 3 am I distributing with the one I'm pointing at here? Okay. Have those finished. So 1, 2, 3, 4, 5. Have those finished for when?
Tomorrow.
Tomorrow, okay? That's kind of your homework. That's the one that would be due tomorrow. I got a short book page. It's not going to be due until Thursday. So you may want to take a second and write this down. I think we're in pretty good shape with this, but please write this down. You are on page 200, and I better look and make sure what page it is.
253.
I think it's 257.
Two-
But I could be wrong.
57. 255. Yeah.
Starts actually on page 258. I want you to do problems 8 through 19. Let's see, today's Tuesday, right? So for Thursday. And guys, save number 19 because I'm going to talk about number 19 with you guys. I want to do number 19 together.
So don't do that.
So if you get to it and you want to try it, feel free to try it. Just know in the back of your mind that if you do get to 19, that at some point we're going to take a look at that together in class tomorrow. Okay? So make sure you take the time to get that out. So the only thing I want for tomorrow is how many problems?
5.
5. And then this 8 through 19 stuff, when's that due?
Thursday.
After I get through a couple things tomorrow, you're probably going to have, probably about 2/3 of class time to work on some things. So have that in the back of your mind as well. All right? Now, I'm going to go ahead and hand out this quick quiz. Put your name on it, don't start. I want to allude you to one thing. I think there's some there. Okay, does anybody need that up there any longer? All right, I'm going to go ahead and stop.